Okay, guys, so I am going to go over these 6.2 proofs just for time purposes on Thursday, okay? So we're here at the section 6.2 notes, and we're going to go over the last two proofs on this page, okay? So here's our first one. Let's go ahead and let's write out the given, all right? So I'm going to go ahead and state that I have parallelogram ABCD, and DE is congruent to FB. And that's through given. Okay. And then I'm going to mark on here that DE is congruent to FB. So let me tell you guys, all right, what we're trying to prove is that angle 1 is congruent to angle 2, all right? And the name of the game for these proofs, even though we're in this polygon section, is actually triangle congruency, all right? That's really going to be what's helpful. So here's what we're going to do. We're going to essentially try to prove, all right, that these two triangles right here are congruent so that we can then state using CP/CTC, all right, that the corresponding parts, all right? So again, writing down that game plan is we're going to prove the triangles as congruent, and then we're going to use CP/CTC, all right, which remember says corresponding parts of congruent triangles are congruent, okay? So how do we do that? So we have the side DE and FB are congruent, all right, but then we're only given that it's a parallelogram, and that doesn't seem like a lot, but if you remember, we actually have 7 different properties that are true about parallelograms, right? And that's that the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other, etc., okay? So if I was doing this, I would remember, oh, well, the opposite sides are congruent, right? Which means that I know that AD has to be congruent to CB. And I'm going to put that in my proof. So AB is congruent to CD. And that's by opposite sides congruent. Okay? Now, what's another property of the parallelogram? Well, I also know that my opposite angles are congruent, which means that angle D has to be congruent to angle B. Oh, and I wrote that down. I'm sorry, guys. All right, this should be that AD was congruent to CB. That's my bad, okay? All right, so like I said, though, that your opposite angles are congruent. So I'm going to state angle D is congruent to angle B. And that's through opposite angles are congruent. And so now if we look at those green triangles that I have there, all right, can I prove them as congruent? And I can because of side angle side, right? Because I have my two sides and my included angle. So now I can state that triangle ADE is congruent to triangle CBF. And that's by side angle side. And so from there then, if I've stated that the triangles are congruent, then I know that the corresponding parts have to be congruent, which means that angle 1 has to be congruent to angle 2 because of CP/CTC. So not bad, all right? So really we're just trying to prove triangles as congruent, all right, using our properties of parallelograms, okay? Which brings us into this one. So it's the same idea, all right? Honestly, guys, it's the same exact idea, all right, here where we're trying to prove triangles as congruent so that we can use that the corresponding parts are congruent, okay? So let's write out our given. So I have parallelogram GHI/J, and I have HP is congruent to JQ. And that's my given. Okay. All right, so let's see what we have here. So what we're trying to prove is we're trying to prove that PX and QX are congruent. All right. So what we're really trying to prove here, guys, is that this green triangle right here is congruent to this triangle right here so that we could use CP/CTC. Okay. Now, we actually have to do a lot of work here. So here is where I actually want to start, okay, is if you look at those two triangles, what can we automatically mark? Well, we can mark that the vertical angles are congruent. So I'm going to do that, and then I'm going to put that in my proof. So I'm going to have that angle PGX. oh no, I'm sorry, PXG is congruent to QXI, and that's because of vertical angles. So we have that in there, all right, and everything else is going to be a little bit more difficult, okay? And so what I want you to look at is this angle and this angle right here, okay? And I'm going to tell you that they're congruent, but the reason why they're congruent is because they're alternate interior angles, right? And the reason why alternate interior angles are congruent is because the lines are parallel. So what we have to state first, all right, in our proof is that this side of GH has to be parallel to GI so that we can use the alternate interior angles. So I'm going to now state that side GH is parallel to side JI, and that's by the definition of parallelogram. You could have also said like op sides parallel, okay? And because we know that those lines are parallel, we now can state that the alternate interior angles are congruent. So now I can state PGX is congruent to QIX, and that's by alternate interior angles. Okay. So we have two angles. We have to get a side in here somehow, right? And let's take a look at the fact of what we haven't used yet, which is that HP and JQ are congruent, right? We have that those are congruent. And so what we also have is that the opposite sides have to be congruent as well. So here's what I'm kind of guiding you guys into, is that we're going to have to use like segment addition, substitution, subtraction in order to prove these two sides right here are congruent. Or those, yeah. All right, GP and QI, okay? So in order to do that, I'm going to state then that the full side of GH has to be congruent to the full side of JI. And that's by opposite sides congruent. And I'm going to now do a definition of congruent step where I'm going to do GH equals JI. And then in my given, I'm also going to restate HP equals JQ. And that's by definition of congruence. So we're going to use segment addition now in order to prove that GP and QI are congruent, all right? So I'm going to use segment addition for GH. So I'm going to do GP plus PH equals GH. And then I'm going to do JQ plus QI equals JI. And so that's through seg-add, segment addition. And so now we just have to do this grunt work of chapter 2 stuff, all right, where I'm going to now take my two segment additions and set them equal to one another. So JP plus PH equals JQ plus QI. And the reason why I can do that is I'm given GH is equal to JI. So I'm essentially just taking this and plugging into my GH, taking this, plugging into my GI to get what I just wrote. All right, so that's through substitution. And I'm going to now state, all right, that I know that HP, all right, is equal to JQ. So I'm going to take this JQ and plug it in for my HP right there. So I'm going to have GP plus JQ equals JQ plus QI. And so that's also through substitution, which means that I can now subtract the JQs. So I'm going to get GP equals QI through subtraction. So I'm going to now set those congruent to one another, all right, using a definition of congruence. And that's really good because we are now ready, all right, once I write that down and once I mark it on my picture, all right, to state that those two green triangles are congruent. So I can now state that triangle PGX is congruent to triangle QIX because of angle side or angle side. And now that I've stated those two triangles are congruent, I can now state, all right, that the corresponding parts of PX is congruent to QX, and that is by CPCTC. All right, guys, that was a long proof. I don't think it's necessarily too difficult, all right? Because once you got to this part right here, it's stuff that we've done, all right, for the last couple chapters. All right, so those were about 5 steps of just grunt work from chapter 2 in order to get to what we needed to do, which is to prove the triangles as congruent. So I hope that makes sense. We're going to be doing more of these and more of stuff based off of section 6.3 on Thursday. And yeah, all right, hope that made sense.